We'll work out a problem in this lesson. In this problem, you have a sphere of radius r is equal to 25 centimeters. The sphere is shown here. The radius AC is given to be 25 centimeters. It is held in position by a rope BC. Okay, so going from end B, which is attached to the wall, and the end C, which is attached to the center of the sphere, its length is 100 centimeters. So you have BC. Let us represent the length by L is equal to 100 centimeters. It is held in position as shown here. If the weight of the sphere is 1000 Newton, that 1000 Newton force will be acting at the center of gravity of the sphere, and its magnitude is given to be 1000 newtons, which will be acting vertically down. Okay, if the weight of the sphere is 1000 Newton, find the tension in the rope BC. Okay, the tension in the rope, for convenience let us represent by S, and the reaction at point of contact A. Okay, and we are assuming that the wall is smooth. Because the wall is smooth, the reaction exerted by it is perpendicular to the surface of the wall, and we can show the reaction here. Okay, let us represent the reaction by RA, this angle being 90 degrees. Okay, to solve this problem, we'll try to draw the free body diagram of the sphere. By noting all the forces acting on the sphere. So we'll draw the sphere first. Okay, that's about as round as I can get, and indicate the forces. One force obviously is the force of gravity, which is going vertically down, and we are representing it by W. The other force is the reaction, which is touching the sphere as shown here with the direction indicated. The second force is RA as shown here, and the third force is the tension in the rope. We know that tension in the rope goes in the direction of the rope, so you have the third force as indicated here. Having drawn the free body diagram, we see the two of the forces W and S, they are meeting at one point. Okay, because they are meeting at one point and all the three forces keep the body in equilibrium, this RA must pass through the center C, where the other two forces S and W meet. It remains for us now to find this angle theta and then apply Lamby's theorem. This angle theta is the angle at C as shown here, and this angle we can very quickly find out. Cos theta in triangle ABC, cos theta is given by adjacent side AC and hypotenuse BC, which is equal to 25 divided by 100, which is equal to 1 divided by 4. That immediately implies sin theta, which is under root 1 minus cos square theta, is easily obtained as under square root 15 by 16. Okay, having obtained these two angles, we will try to draw the we will try to invoke Lamby's theorem for the sphere. okay, Lamby's theorem for the sphere, okay, and indicate all the three forces as shown here. You have one force W going down vertically, okay, and the other force RA going horizontally to the right. Let me quickly label them. This is the weight W, this is the reaction RA, and the third is the tension in the rope, which is going up and to the left. So this is tension in the rope S, okay, and we may note that this angle is theta, which we have already computed here. We have computed cos theta and sin theta. We can note down the three angles between the forces between RA and S. This is the angle, and this angle we can write as 180 minus theta, because this whole all from here to RA is 180 minus this angle theta. 180 minus theta is the angle between S and RA. Between RA and W it is 90 degrees, and between S and W, which is this angle, we can show it as 90 plus theta. You have this is 90 degrees and you have a theta. Having noted this, we can write the equation for Lamby's theorem as, you have S divided by, this is S, and divided by sine of angle between the other two. The angle between the other two forces W and RA is 90 degrees, so you have S over 1 is equal to, the other force is RA over sine of angle between the other two forces, that is S and W, is 90 plus theta. Sine of 90 plus theta is cos theta. This is equal to, you have the third force W is shown here, divided by sine of angle between the other two forces. This angle is 180 minus theta. Sine of 180 minus theta is sine theta itself, from which you can write, you have S is equal to, W is 1000 divided by sine theta is given as under root 15 by 16. Okay, this value can be quickly computed. Let me try to bring up the calculator. Okay, the calculator is here, so we punch in 1000 divided by, bracket open, 15 divided by 16, bracket close, yth root 2 is equal to, you have 1032.8 Newton, and we can write RA is equal to, you have W over sine theta, which we have already computed to be 1032.8, multiplied by cos theta, which is 1 over 4. So this 1032.8 divided by 4 is 258.2 approximately. Okay, and these two constitute the answer for us. Okay, that is what is asked in the problem, and that is what we have found out. Okay, almost all the problems using this Lamby's theorem, that is 3 concurrent forces in a plane, they involve drawing a free body diagram, computing the unknown angle theta, and then drawing the force diagram and applying Lamby's theorem. We'll try to see subsequent topics in lessons that follow.